I have all I need inside me. I have opportunity. I have all the strength I need to succeed. I have all the strength I need. I have limitless potential. I have all I need. I have opportunity. I have all the strength I need to succeed. I have all the strength. I am grateful for all I have. I am grateful for my life. I am grateful for my health. I am grateful for my desire. I am grateful I was born with fighting spirit. I am grateful for my strength. I will use my strength every day. I will use my spirit every day. I will give my all every day. I am determined. I am willing to sacrifice. I am willing to go the extra mile. I will go the extra mile. I will do whatever it takes. There is nothing I cannot have. No one I can't become. I have no limits. I will achieve whatever I set out to achieve. I will achieve my goal. I see my goal clearly. I know when I will achieve my goal. I know how to get there. I will achieve my goal. I will be great. I have set the date. I will not be late. I will be great. I have limitless potential. I have all I need inside me. I have opportunity. I have all the strength I need to succeed. I have all the strength I need. I have limitless potential. I have all I need inside me. I have opportunity. I have all the strength I need to succeed. I have all the strength I need. I have limitless potential. I have all I need inside me. I have opportunity. I have all the strength I need to succeed. I have all the strength I need. I am determined. I am willing to sacrifice. I am willing to go the extra mile. I will go the extra mile. I will do whatever it takes. There is nothing I cannot have. No one I can't become. I have no limits. I will achieve whatever I set out to achieve. I will achieve my goal. I will do whatever it takes. I will do whatever it takes. I will be great. I have set the date. I will not be late. I will be great. I am a winner. I am a fighter. I am a beast. I am a machine. Success is mine. There is no doubt. It is mine. I can. I will. I will. I will achieve whatever I set out to achieve. I will achieve my goal. I see my goal clearly. I know when I will achieve my goal. I know how to get there. I will achieve my goal. I will be great. I have set the date. I will not be late. I will be great. I have limitless potential. I have all I need inside me. I have opportunity. I have all the strength I need to succeed. I have all the strength I need. I have limitless potential. I have all I need inside me. I have opportunity. I have all the strength I need to succeed. I have all the strength I need. I have limitless potential. I have all I need inside me. I have opportunity. I have all the strength I need to succeed. I have all the strength I need. I am determined. I am willing to sacrifice. I am willing to go the extra mile. I will go the extra mile. I will do whatever it takes. There is nothing I cannot have. No one I can't become. I have no limits. I will achieve whatever I set out to achieve. I will achieve my goal. I will do whatever it takes. I will do whatever it takes. I will be great. I have set the date. I will not be late. I will be great. I am a winner. I am a fighter. I am a beast. I am a machine. Success is mine. There is no doubt. It is mine. I can. I will.
Good evening. We'd like to welcome you to another session with Mathematics Demystified. And we'll be continuing our session on theory of logarithms. During the last class, we looked at the 5 basic laws of logarithm. We looked at the product law, the first law, the product law, which says that log p multiplied by q is equal to log p plus log q. That means the logarithm of the product of two numbers is equal to the addition of their individual logarithms to the same base. Then we looked at the second one, which is the division law, and we stated that the logarithm of the division of two numbers is equal to the subtraction of their individual logarithms. Thus, we said log p over q is equal to log p minus log q. And we emphasized the fact that log pq is not, log p plus q is not equal to log p times log q. In the same way, we said that log p over q, which is equal to log p minus log q, is not equal to log p over log q. We emphasized that. Then we went on to the third law, which states that the logarithm of a number to a power will be equal to the power multiplied by the logarithm of that number. For instance, we said log p raised to power n is the same thing as n multiplied by log p. Then we looked at the fourth law. This says that the logarithm of a number with the same base, logarithm of a number to the same base is equal to 1. So for instance, if you have log 5 to base 5 is equal to 1, log a to base a is equal to 1, log 10 to base 10 is equal to 1. Then the last law, we looked at the last law, which says that the logarithm of 1 to any number, the logarithm of 1 to any number is equal to 0. The logarithm of 1 to any number is equal to 0. So today we want to continue, we want to look at some exercises. Then we'll briefly look at the last assignment that we gave out. So this is saying that these examples, the exercises, are saying that simplify the following without the use of tables. Simplify the following without using tables. The first one says the solution is already here. So the first question is log 4 over log 2. That's the question. Log 4 divided by log 2. Now, log 4 divided by log 2, we say is the same thing as log 2 raised to power 2, because 4 is 2 raised to power 2. So we can express that. We can express log 4 as log 2 raised to power 2, then divided by log 2, which is the same thing as 2 log 2 divided by log 2. Then log 2 can cancel each other. This log 2 can cancel this log 2, so that we'll be left with 2. So log 4 over log 2 is equal to 2. I hope that is clear to us. I will want you, probably at your leisure, when the class is over, you can verify using your logarithm, using your calculator or your logarithm table. Look for log 4 divided by log 2. You will definitely get 2. Then the next one is saying log root 3. The logarithm of root 3 over logarithm of 9. Logarithm of root 3 over logarithm of 9. Now, logarithm of root 3 if we go back to our law of indices, root 3 is the same thing as 3 raised to power half. So we will change this. Instead of writing log root 3, we have log 3 raised to power half. Then 9 is the same thing as 3 raised to power 2. So that log 9 would be log 3 raised to power 2. Now, log 3 raised to power half is the same thing as half log 3. Then log 3 raised to power 2 is the same thing as 2 log 3. So log 3 will cancel log 3, so that we will have half divided by 2. Half divided by 2, which is the same thing as half multiplied by half, which will give us 1 over 4. The next one says log 0.2 divided by log 25. Log 0.2 divided by log 25. This is the same thing as we'll express this log 2 as in index form. If you look at 0.2 as a fraction, you can change it to, as a decimal, you can change it to fraction. And if you change 0.2 to fraction, it's 1 over 5. 1 over 5. So 1 over 5 is the same thing as, if you look at the laws of indices, 1 over 5 is the same thing as 5 raised to power 1. So that log 0.2 will be the same thing as log 5 raised to power 1. Then log 25 will be equal to log 2 raised to log 5 raised to power 2, because 25 is 5 raised to power 2. So in the same way, using our third law of indices, third law of logarithm, log 5 raised to power minus 1 will be the same thing as minus 1 multiplied by log 5. And log 5 raised to power 2 will be 2 log 5. So log 5 cancels log 5, so that we have minus 1 over 2. So our answer is minus 1 over 2. Then the third one, the last one under this category, says that log 8 minus log 2, everything divided by log 4 minus log 2. Log 8 minus log 4, we divide everything by log 4 minus log 2. Now, if you look at this, we can rewrite this using our second law of logarithms, so that this will become log 8 over 4. Then we can also rewrite the denominator as log 4 over 2. So if you divide 8 by 2, you have 2. So that log 8 divided by 4 will give us log 2. Then log 4 divided by 2 will give us also log 2. So log 2 cancels log 2, so that we will have 1. Now, if you observe carefully, one thing you need to always attempt to achieve, is that you express the numbers you express the logarithms such that you will have a common number. You do it such that you will have the logarithm of a common number. For instance, when we're looking at log 0.2, and this is 25. So how can we express, we know that we can express 25 as 5 squared. How can we express 0.2 in terms of 5? That's why we have to divide 0.2 by 10 to give us 1 over 5. So every problem you are given in this format, or in logarithms generally, all you need to do is just to attempt to express them with a common logarithm, so that you can easily solve them. I hope that is clear to us. So the next we're going to look at is this question. They said, if log x minus log 2x minus 1 into bracket is equal to 1, we should find log x. If log x minus log bracket open 2x minus 1 bracket close is equal to 1, find x. Now, in this case, the first thing we do is we will express the left-hand side of the equation using the second law of logarithms, so that this log x minus log 2x minus 1 will become log x over 2x minus 1, log x over 2x minus 1. Then, if you read the instruction we had at the beginning of these exercises, we were told that we were working with base 10, that all our problems within base 10. So we also express 1 in logarithm to base 10. And if you look at the fourth law of logarithm says that the logarithm of a number to the same base is equal to 1. So instead of having 1 here, we'll express 1 as log 10, because log 10 to base 10 is equal to 1. I hope that is clear. So, as I've just mentioned, by applying the division law of logarithms, we'll have logarithm of x divided by 2x minus 1 is equal to logarithm of 10. So the logarithm can cancel out each other. The logarithm will cancel out, so that we will have x over 2x minus 1 is equal to 10. So if the logarithm cancels out, we will have x over 2x minus 1 is equal to 10. So if we cross multiply, we will have 2x minus 1 multiplied by 10 will be equal to x. That's what we have here. So if you open that bracket, you have 20x minus 10 is equal to x. 20x minus 10 is equal to x. So if you collect like terms, you have 20x minus x equal to 10. Thus, if you subtract x from 20x, you have 19x equal to 10. So divide both sides by x by 19, you will have x equal to 10 over 19. X will be equal to 10 over 19. All right. During the last class, we had some assignments. I gave out some assignments, and I want us to quickly look at the solutions. I want us to briefly look at the solutions to the assignment. So the question 1 says, given that log 2 base 10 is equal to 0.3010, log 3 base 10 is equal to 0.4771. We are asked to calculate, without using mathematical tables or calculator, the values of log 5.4 to base 10 and log 0.24 to base 10. Now, if we look at this, so for the first one, log 5.4, we can express 5.4 as 54 over 10, because we are working with base 10. So we can express 5.4 as 10, as 54 over 10, or you can also say that your log 54 is equal to 2 times 27. You know, 2 times 27 is 54 divided by 10. So log 5.4 is the same thing as log 2 times 27 divided by 10. Then, which will equal to, if you now apply the law of logarithms here, you will combine the first and the second. This will now give us log 2 plus log 27 minus log 10. Log 2 plus log 27 minus log 10. Now, what we do is we will attempt to express all this, log 2, log 27, and log 10, to in terms of 3 and 2, because we are only given the values of 3 and 2, sorry, log 3 and log 2. So we would tend to express everything in terms of log 3 and log 2. So log 2 is already there, so we leave that plus. Now, 27 is the same thing as 3 raised to power 3. So instead of having log 27, we'll have log 3 raised to power 3. Then we have our log 10. So we can further break this down. We can further break this down to 3 log 3 to the base of 10. So that we will have log 2 plus 3 log 3 minus log 10. Log 2 plus 3 log 3 minus log 10. So this will be, we have log 2 to be 0.3010. Then log 3 is 0.4771. Now, if we look at this, we were not given log 10, but we know that from our fourth law of logarithms, we know that the logarithm of any number to the same, with that number as the base, is the same thing as 1. Logarithm of a number to the same base is 1. So log 10 base 10 will be 1. So that we have 0.3010 plus 3 multiplied by 0.4771. This is log 3, then minus 1. So if we put in all this and we add and subtract, we'll have 0.7323. So our log 5.4 to base 10 will be 0.7323. I will want you to try something out. You can get your calculator and press log 5.4. Press log 5.4, and then I can assure you that you will have the same answer. So the next one says log 0.24. The same way, is the same way. Log 0.24, 0.24 can be expressed as 24 over 10. 0.24, sorry, can be expressed as 24 over 100. 0.24 can be expressed as 24 over 100. So that we will have 24 can also be broken down into 3 times 8. So that our log 0.24 will be log 8 times 3 divided by 100. So the whole of this, 8 times 3 over 100 is our 0.24. So in the same way, we split it out using our laws of logarithms, so that we have log 8 plus log 3 minus log 100. So log 8 can be expressed as 2 raised to power 3. 8 can be expressed as 2 raised to power 3, so that we'll have log 2 raised to power 3 plus log 3 is equal minus log 100, which is the same thing as 10 raised to power 2. So if we express this, log 2 raised to power 3 is the same thing as 3 log 2, 3 multiplied by log 2, plus log 3 minus 2 log 10, minus 2 log 10. So log 2 we have been given to be 0.3010. So we have 3 multiplied by 0.3010 plus log 3, which is 0.4771, minus 2 log 10. Log 10 base 10 is 1. So minus 2 times 1, which is 2. So if we multiply 3 by 0.3010, we have 0.9030 plus 0.4771 minus 2. And everything will give us minus 0.6199. And in the same way, if you use your calculator to find the logarithm of 0.24, I can assure you, you will have minus 0.6199. I want to believe that is clear to us. Number 2 says evaluate without using mathematical tables or calculators. Evaluate without using mathematical tables or calculator. log square root of 30 to base 10 minus log square root of 6 to base 10 plus log square root of 2 to base 10. Now, we don't have to allow the root sign to scare us. We don't have to allow the root sign to scare us. And since all the terms have roots, you can just do them the normal way, which implies that if you apply the laws of logarithm, this will be the same thing as log root of 30 multiplied by root 2, so that you will have root 30 multiplied by root 2, then divide by root 6. Root 30, logarithm of root 30 multiplied by root 2 divided by root 6. So that we have, as I said, this will be log square root of 30 multiplied by square root of 2 divided by square root of 6, which will give us, if we multiply square root of 30 by square root of 2, we get square root of 60 over square root of 6. So square root of 6 can divide square root of 60. You have square root of 10. Because 6 can divide 60 to give us 10. So that we will have, this will now become log square root of 10. Now, square root of 10, we can rewrite it as 10 raised to power half. Square root of 10 is the same thing as 10 raised to power 1 over 2. So if we rewrite that, we have log 10 raised to power half to base 10, which will give us half log 10 base 10. And we know that log 10 base 10 is equal to 1. So this becomes half multiplied by 1, which will also be half. The other one says evaluate log 3 over 5 to base 5 plus 3 log 5 to base 3 log 5 over 2 to base 5 minus log 81 over 8 to base 5. The same way, all what you just need to do here is split this. We will split log 3 over 5 to become log 3 minus log 5. Then we will apply this power to everything in this bracket, so that the whole of this will now become log 5 raised to power 3 minus log 2 raised to power 3. Then this last term will become log 81 minus log 8. So, and we know that this is what I just explained now. Log 3 over 5, it will be the same thing as log 3 minus log 5. Then 3 log 5 over 2 is the same thing as 3 multiplied by log 5 minus log 2, everything in bracket. Then the last part, log 81 over 8, is the same thing as log 81 minus log 8. So if we open this bracket, and also express, 81 can be expressed as 3 raised to power 4, then 8 can be expressed as 2 raised to power 3. So we also break that down, so that this becomes log 3 minus log 5 plus 3 log 5. That if you open this bracket, you have 3 times log 5. 3 times log 5 will give us 3 log 5. Then 3 times minus log 2 will give us minus 3 log 2. Then minus log 81 is log 3 raised to power 4. Then log 8 is minus log 2 raised to power 3. So if we bring, for all the ones that have powers, if you bring the power to use the power to multiply the logarithms, you have log 3 minus log 5 plus 3 log 5 minus 3 log 2, then minus, this becomes minus 4 log 3, which is this, minus 4 log 3, then minus 3 log 2, minus 3 log 2. So if we look at what we have right now, we have everything to the base of the logarithms we have here now are the logarithms of 2, logarithm of 3, and logarithm of 5. So what we do is we collect like terms. We put all the logarithms of 2 together, put all the logarithms of 3 together, put all the logarithms of 5 together, and then simplify them, which is what I said. We collect like terms. We have log 3 minus 4 log 3, then minus log 5 plus 3 log 5, then minus 3 log 2 minus 3 log 2. So that log 3 minus 4 log 3 will give us minus log 3. Sorry, minus 3 log 3. This will give us minus 3 log 3 because 1, there's supposed to be a 1 here, but usually you don't write it 1. Minus 4 will give us minus 3, so that we have log 3 minus 4 log 5 to be equal to minus log 3. Then you have minus log 5 plus log 3. This is the same thing as saying log 3 log 5 minus log 5, which is, this is 3, this is 1. 3 minus 1 will give us 2, so that we will have 2 log 5. This becomes 2 log 5. And this is minus 3 log 2 minus 3 log 2 minus 3 will give us minus 6 log 2. So, which is what we have here. We have minus 3 log 5 plus 2 log 5 minus 6 log 2. Then we can use our law of logarithm. We can now apply the law of logarithm to simplify this further and say you put the power, all the numbers before the log, you put them as power and you express them, so that we will have our log 2 log 5 will become log 25, which is this, minus 3 log 3 will become minus log 27, which is this. Then minus 6 log 2 will be minus log 64, because 2 raised to power 6 will give us 54. 3 raised to power 3 will give us 27. 2 raised to power 5 will give us 25. So if you put this together, this will now give us log 25 over log 27 times 64. Log 25 over 27 times 54. So that is the end of what I have for you guys today. I will want to appreciate